So we started out with a set of slides that was a bit more austere than some of the other groups, and realized we just have so much research to cover and get through that kind of coming up with a summary of everything is a little bit challenging. So briefly, I'll say that there is a large body of air pollution health research, and there are well-established associations between various air pollutants and respiratory, cardiovascular, and cancer outcomes. There are other health endpoints that have been increasingly associated with air pollution, developmental, cognitive, and so forth. And we have also had significant work on mechanistic pathways. Due to the complexity of the research, the number of pollutant species that are out there to be assessed, potential nonlinear relationships both between sources and pollutant concentrations in the atmosphere, and between those concentrations and the health outcomes, the importance of spatial and temporal scales, the importance of exposure within microenvironments that are difficult to assess at a population level, as well as the often discussed environmental health disparities, and I should also say interaction with a number of other factors that have been discussed today and will continue to be discussed in the neighborhood factors session next. So these challenges all provide us, although we have a well-established body of research, they provide us with opportunities and priorities to move forward. So the first priority that we identified was further development and refinement of our spatial and temporal air pollutant surfaces. So we're in a little bit better shape maybe with our spatial surfaces. We have a fairly good spatial resolution for a couple of major pollutants. We don't think that realistically we're going to drill into modeling separately every single pollutant, but we do feel that there's a need to update the model surfaces that we have. So we have surfaces based on land use regression model for about 14 Canadian cities with varying time periods from the early 2000s up until just this past year. We have satellite surfaces that are available annually, monthly for the past 10 years. We have a number of chemical transport models developed by Environment Canada, Environment Climate Change Canada, and others in academia. And we have models that hybridize those that represent a combination. So again, some of those models need to be updated, specifically the land use regression models. Some of the atmospheric models need to be developed to a finer spatial resolution. And the satellite estimates obviously can be improved by new satellite data. Finally, of course, the linkage of air pollution data to health cohorts, which is ongoing. In terms of the temporal resolution, we're a little bit further behind in that area. The satellite surfaces do provide a temporal resolution based on the differences in the observations initially collected by the satellite. Some of the chemical transport models obviously provide a temporal resolution. Land use regression models do not provide a temporal resolution. These can be combined with other sources of information to try to sort of present a temporally scaled estimate, but none of these methods are perfect, and there's a lot of agreement that we can at least try to do better. So our goals here are to provide stronger estimates of these fine-scale temporal resolution, to expand our historical coverage to better support longitudinal cohorts. We have an interest in looking at ensembles of different types of models. So, and this is I guess, more explicitly with respect to developing different chemical transport models and then comparing those outputs, but also as we aggregate the data and provide it to the CANUE consortium platform, to use that as an opportunity to do some comparisons and to see how the models perform compared to one another. In terms of oxidative potential, this is something that I think comes out of a place where we recognize that we can't assess every individual pollutant. So instead of trying to do so, we say, is there another measure that can capture the health impacts of a mixture of pollutants? And that's where oxidative potential comes in. This is a much newer methodology. So the focus here is really doing more methods development. There's been a lot of promising work in this area, linking increased oxidative potential with health effects, oxidative potential in PM with health effects, based on oxidative potential of measurements at regulatory monitors. So the next step is to develop that into a spatially resolved surface, and then obviously, again, link that to cohorts. And then I think I'll turn it over to my colleague, Amir.
Okay, following on the priority areas that we identified, and this was through essentially a feedback, a few calls that we had with a fairly large group of researchers in air quality. One of the areas was source characterization, with the speculation that the health effects of the mixture of pollutants would have a correlation with where they come from, with the source of pollution. And there's quite a bit of activities on the source characterization, either planned or currently underway. One of them, more traditionally, we're familiar with, are source apportionment studies that have been done. And I think that there is a wealth of data, I guess, and maybe I should be corrected on that, maybe at Environment Canada, that could become available on statistical source apportionment methods like CMB and PMF. And then we're planning to do using CTMs, and I apologize, CTMs are essentially air quality models. We took it for granted that everyone is familiar with the acronym. Basically using these physical models to link the health impacts or concentrations and health impacts back to sources. And one main question is how much agreement we see between those statistical methods of source apportionment and physics-based source attribution methods. Then one idea is that rather than having surfaces that are specifically on concentrations, can we find associations between source surfaces and cohorts in combination with longitudinal cohorts? So these are parts of the projects that are underway. And then obviously a very important part when it comes to sources are the transportation part and distinction between different types of transportation emissions that we can have. And a big part, a growing part of the effort is also taking advantage of satellite observations, the wealth of information that is available from satellite observations, and finding essentially through sensitivity simulations, inverse modeling, better understanding the sources that are contributing to concentrations. Following on the satellite front, I think two of the researchers that are present in the room, Brandon Martin and Chris McLendon, basically identified areas that they thought are near-term or mid-term or long-term research topics. One of them is introduction of GOES-16, which is the first North American geostationary satellite for air quality, for atmospheric composition. So that's essentially a satellite that is always views North America rather than just certain times of the day. The product would be a PM product. This is just launched, so it's Randall considers to be a short-term product that can become available. NO2 and SO2 estimates from Tropomi, which is scheduled to be launched fairly soon, and also NO2 and SO2 estimates from Temporal that is also scheduled to come into effect. And pretty much along the same lines from Chris, again, the same pollutants as before, in addition to ammonia, and I'm not sure what instrument that is, but essentially along the same lines. Another area that came up repeatedly in our discussion with the group was integrated indices that can describe the state of air pollution, both relating them to sources, but also understanding or recognizing that air pollution is a mixture and should be essentially viewed as such. And development of those indices, I think Randall and I know Jeff, there's quite a bit of interest, both in Canada but also in the US, and they are planning on using various satellite products to come up with indices that are representative of the type of air pollution mixture that we can have, relating again to the sources or just the atmospheric composition, indicators for different atmospheric compositions. And similar to the idea of air quality health index, another idea is whether we can come up with indices that describe the long-term health impacts of air pollution, again from satellite or spaceborne observations. And obviously, one of the main ingredients of CANUE, if we can do that on a multifactorial basis that considers all different exposure parameters. There's great interest in following up on the PLACE project, Paul's project that we want to see if we can find a venue for funding, and following the goals of that, again, that multifactorial exposure assessment and also health outcome assessment. And as well as community tools like AQHI, but within new indices that we can envision. So if we go through the list of things that are available in the short term or long term, and I think I will go through these very quickly, essentially the same items that very briefly we discussed. I think the short term items are a suggestion by Mike Brard that on the temporal side, there's a lot to be achieved that is not consolidated in terms of methodology, but also in terms of data that can be done in the short term. And also linkage of what is available in cohorts, what is available in terms of exposure data to cohorts. More midterm, a number of projects, including what Environment Canada is planning to do in terms of providing fused air quality model and surface observation data, what is called objective analysis, back to a few years back, and also later on in midterm extending that all the way back to 2000. And a project that Markey and I are working on, again, fusion of air quality models and LURs. I'm not going to go through all the lists. I think one area is also ensembles. If we can basically get surfaces from various methods or various models, and in that sense come up with a measure of uncertainty. Uncertainty is one of the themes that didn't really come up as much today, or I think hasn't come up as much today in the evaluation of exposures that we have talked about so far, which is still a very important factor, but I think either we don't really have the tools to quantify the uncertainty for most of the exposure types, satellite observations excluded, or we haven't really put enough efforts in it. In terms of source characterization, we are hoping to, in the midterm, to basically have source attribution results and then also compare them to statistical source apportionment. Oxidative potential, this is projects that are going on with at Health Canada, but also with Greg's group. I think these timelines are probably optimistic. Scott Wakenthal, who's in charge of that work, thinks that this is probably more in the long term rather than midterm. And in terms of community tool, I guess, because those ideas are more at the inception phase, I think more long term, and obviously the linkage with cohorts are as soon as they become available. And I'll pass on to Markey.
So the blessing and the challenge of the air quality team is that a lot of the priorities that we identified are being addressed by studies that are already funded. So our real challenge is to make sure that all of the different investigators working on these research areas are coordinated so that we can avoid some of the redundancies we can make sure to have the strongest final product, and also to make sure that the final data actually does feed back into CANUE and hopefully in a timely way. So again, just a quick run through of some of the studies that we're aware of that, that feed in, and please come to me or Amir or let us know if there are other studies that sort of relate back. But as Amir said, there are a number of studies led by Scott Weichenthal focusing on oxidative potential. I should also mention Crystal Pollett, who provided us with a lot of information, and unfortunately, since she provided her slide, we didn't really go in and put her name in parentheses, we just used her slide as is. So, so she should be acknowledged as well. And there's also the work going on at Environment and Climate Change Canada, led by Richard and Elaine, providing the GEMMAC surfaces and the historical objective analyses based on those surfaces. Daniel Rainham is setting up a wireless sensor network, again, looking at some of the new technologies, which we haven't talked about very much here, but that's one sort of small stab at that. There's Mike Brower's Maple project, which has a number of different moving parts, including air pollution and some of the other factors that are being considered by some of the other groups that have talked today. Errol Thompson at Health Canada is looking at the more mechanistic side, looking at air pollution and stress, and how stress can potentially modify air pollution health effects. Amir and I are focusing on hybrid modeling, combining CTM and LUR models, again, to try to provide temporally resolved historical data, and also to look at some of the source questions. And then there are a couple of studies that are sort of in the works that are, people are planning to submit for funding to look at some of the other issues. Some of these get at environmental disparities, but I'll say that is a bit of a gap. I think we have a couple of ideas on that side that don't have identified funding, whereas I think the raw materials are there to make those projects happen. In other words, we have the surfaces, we have the information, in development, and so it's a question of making sure we go to that next step and provide tools that are useful to the public and to decision makers. So we also came up with some questions, many of which have been answered today. So the relationship between different projects, what makes a project a CANUE project? Is anyone who comes here, or all of your projects now CANUE projects? So, for us, I think that very loosely the idea is, we're hoping that people will provide data to CANUE, in which case, you sort of fall under that umbrella. There's also the potential, obviously, to, leverage the small amounts of funds to make things happen that might not be able to otherwise in some of these existing studies. But that's something that we feel like needs to be sort of further elucidated. We already heard about some of the mechanisms and standards for data submission and curation, which is great, because that's certainly a question that came up during some of our calls and our email exchanges. The lag time, especially for government researchers, so we have a lot of people working on these surfaces, on estimating air pollution, who are working at Health Canada, who are working at Environment and Climate Change Canada, and sort of, and even in academia, making sure that we have a good timeline from, when the surface is developed to when it, can become available for linkage to cohorts. That's important. I think, too, what is the goal for exposure data application? So some of this, came out a little bit in the transportation conversation. So, we know that one of the strong goals behind the development of CANUE was to support health cohorts. And so that's obviously a very important objective, developing exposure surfaces for that purpose. But we also feel like there's a role for development of community tools and policy simulation tools that also support health improvement. So communication, again, that's something I think Jeff addressed a little bit, but it's something that will be of interest to all of us, as we hope that as we develop these surfaces and these tools, that there's a strong program for communicating them. And then finally, this is the CANUE air quality team. So thanks to everybody who contributed, and if we didn't get everybody's ideas, feel free to email us again, and call, let us know what we missed. So thanks.
Question. I think a lot of us here are more on the health outcome side, and we're the end users of exposure data. And one of the challenges in modeling outcomes and exposure is that there is the confounding, you know, by indication or the reverse causality issue, meaning that when you looked at, you know, areas that are highly polluted and the health outcomes is actually good, and that could be people, you know, with a health condition, they moved out of the area with, you know, poor air quality. So when you look at that kind of association, you ended up seeing a negative effect, or, you know, it doesn't make sense. So I just wonder, you know, moving forward, what kind of data that, you know, the air quality platform would want to consider collecting that will allow us to evaluate this kind of association. And along that side also, you know, people with let's say asthma or COPD, and they learned over time that, you know, on a bad day, it would exacerbate my asthma. So they learn and they stay out, they stay indoor and not being exposed. And again, when you measure the outcome, the impact of air pollution, there is none, because, you know, people stay inside and not being exposed. So how are we going to deal with that type of reverse causality or confounding by indication?
Well, I'll take a stab at that, and my first thought is that I don't think that the air pollution services alone are going to address that, right? So that's not a surprise. I think that, you know, one of the strengths that CANUE brings together is that we're looking at all these other factors, right? So you can, instead of doing a study that just looks at air pollution and considers that in isolation, you can do a study that looks at air pollution as well as pollen, as well as noise, as well as, you know, the other different factors that may explain some of those unexpected associations, or, you know, and the other thing I'll say is that there's a wealth in Canada. You know, we were just talking about air quality here, but there's a wealth of cohorts, right? Longitudinal cohorts, and one of our goals is to support the cohorts. So by providing that historical data, better historical data, by, you know, getting a better sense of quantifying our uncertainties, by providing better temporally refined data, that hopefully we can help support cohorts that have the information to answer those questions potentially, right? So, you know,